Okay, let us see how this Cohen-Sutherland line clipping work with this example. So in line clipping, the line which is partially inside and partially outside, okay, partially inside and partially outside here, we need to find the intersecting point. So in previous slide, we have derived two formula here. Okay, in the previous slide, we have derived two formula here to find the x and y of the intersecting point. So based on this problem, we have to find the line segment of this P1 and P2. Okay, P1 and P2. So we need to find the intersecting point of this line. Okay, here is the intersecting point and also intersecting point of this line as well. So first, we need to use the region code. Okay, we need to find this first. Okay, you're gonna find this intersecting point first. So P1. Okay, let's look at to this P1. Okay, P1 is on which region? Okay, P1 is located here. So I hope that you still remember the region code for this. So the region code for this area or this region is 0001. Okay, and what is the region code for P2? Okay, P2 is located in this region. Okay, so what is the region code for P2? Okay, P2 is the 1000. Okay, 1000. So we need to perform the logical AND operation for this P1 and P2. Okay, to check after we do an AND operation, we will get 0 or not. Okay, so we do an AND operation. So 1 and 0 is 0, 0 and 0 is 0, 0 and 0 is 0, and then 0 and 1 is 0. So you get all 0 here, 0, 0, 0, 0. So the answer here is you get 0. So that's mean that we need to find the intersecting point because the line is partially inside and then partially outside. So let us find the intersection point. To find this value, okay, to find this value, here the intersecting point of this value, we need to consider this point as the x and y. Okay, x and y is the coordinate of this intersecting point. So this intersecting point of x and y, and based on this clipping window, they already provide the coordinate of each border already. Okay, they provide you with this coordinate, 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 and coordinate. So this means that we can use this value to find the intersecting point. So let us write it down this information so that we can use it later. Okay. Okay, XW mean is always 50. Okay, XW mean is here. Okay, XW mean is here. So it's mean that it's always 50. And then XW max is always 80. Okay. This one is 80, this one is 50. This one is represent XW minimum is always 50. And then XW max is 80. Okay, XW max is 80. It's always 80 here because it's XW max. Okay. And then YW mean is always 10. Okay, YW mean is always 10. And YW max is always 40. Okay, YW max is always 40, YW min is always 10. Okay, so write it down all the information given from the question here. Okay, so now we need to find the intersecting point. Okay, we need to find the intersecting point, so we need to use these two formula. Okay, we need to use these two formula. So let us find the slope or m first. Okay, we need to find the slope, which is the m, which is m is equal to y2 minus y1 by x2 minus x1. Okay, so this is your p1 and p2, your x1 y1 here, and then this is x2 y2. Okay, x1 y1 x2 y2. So use this coordinate to find the slope or the m. So y2 is 45 minus with y1, which is 15, divide by x2, which is 75, minus with the x1, which is 40. So you get the slope is 0.85. Then we need to find the y value first using this formula. Okay, we need to find the y. Okay, so the y value from using this formula, y1 plus m in the bracket is x minus x1. Okay, y1 is from here. Okay, y1 is from here, from this x1, y1, so is 15. Okay, this is y1 is 15. Okay, y1 is 15, and then the slope is m. We just calculate this just now, which is 0.85. So 0.85. And then x. Okay, for x here, we need to observe from this figure. Okay, this x value, we need to observe from this figure. The x here is on the left border here. Okay, is on the left border, which is on the xw mean. Okay, is always xw mean, which is 50. Okay, 50. So your x1 here, your x here is the 50. Is always 50 for x. Okay, because is xw mean. So xw mean, you have write down this info here 50. So write it down here as a 50 minus with your x1. X1 is the 40. Okay, this x. Okay, this x from the xw mean. Okay, minus with the x1, which is the 40. Okay, so you will get the answer of this as the 23.5. Okay, 23.5. Therefore, the intersecting point of this x and y here is the x is 50. Okay, x is always equal to 50. Okay, x is always equal to 50. So you just write down the value of x is 50, and then the y value is from the one that we just calculate just now, which is 23.5. Okay, so you get this intersecting point of x and y here as 50, 23.5 coordinate. Okay, here, so we get 50, 23.5. Okay, so we need to find one more intersecting point here, up here. Okay, we need to find one more intersecting point up here. Again, we need to use the same procedure. Let's look into the next slide. Okay, the next one is that we need to find one more intersecting points of this line segment, which is we done for this intersecting point. One more point that we need to find is intersecting point of here. Okay. Okay, so let us consider this new intersecting point as we need to find here is x and y. Okay, consider this as a x and y. Okay, this is from the previous procedure. And then in order to find this new intersecting point, we consider this as a x and y. And then the y value here, okay, the y value here is fixed, which is always 40. Okay, the y here is always 40 because is on this border. Okay, because the yw max is always 40. Okay, yw max is always 40. So y here is fixed and always 40. So you just write it down here as your y is always 40. And we need to find the x coordinate. Okay, x coordinate. So this is finding the slope like in previous procedure using the y2 minus y1 and x2 minus x1, and then we get the same value of the slope, which is 0.85. Okay, and then what is the formula for x? Okay, in the formula to find an x is x1 plus y minus y1 by m. Okay, using this formula to find x. So x1 is, just consider that this one is x1 and this one is y1. Okay, x1, y1. Okay, here is x1, here is y1. So x1 is 75. Okay, from this formula, x1 75 plus y. Okay, the number of y here is upper here. Okay, upper here, which is from the yw maximum. Okay, which is from the yw maximum, which is always 40. Okay, so y here is 40, which is always 40s, and then minus with y1. Y1 is 45. Okay, y1 is 45 from here, and then by m. Okay, divide by m, which is 0.85 here. So you will get this value as 69.2. Okay, the number of egg here is 69.2. So this indicate that the x and y coordinate for this intersecting point of x and y is 69.2. The x is 69.2, and then y is always 40. Okay, so you get this new intersecting point is 69.2, 40 is here. Okay, 69.2, 40. So this is the coordinate of this intersecting point. Okay, so the part inside here, okay, the part inside here from the 50 and 20.5 and then 69.2 and 40, from here to here, it will be visible and will be seen and will be displayed to the screen. Okay, but from this to this, okay, this to this will be clip and reject. Okay, and then this one until this one also will be clip and also reject. Okay, so the part that is inside this clipping window will be displayed. Okay, the part that is outside will be discarded and reject. Okay, so this is how line clipping algorithm of Cohen-Sutherland work with this example. Okay, after you gone through some basic overview about the line clippings of the Cohen-Sutherlands and also some example that we have learned in previous slide. So let us understand this line clippings algorithm of Cohen-Sutherland by the algorithm itself. Okay, so based on this Cohen-Sutherland line clipping algorithm, the first procedure or first step that you need to do inside this algorithm is that you need to assign a code for each endpoint. Okay, first you need to assign a region code for each endpoint. I hope you still remember how we assign a code for each region. And then if both of the endpoint, okay, if both of the endpoint have a region code of 0000, okay, if both of the endpoint of a region code is 000, so we can just accept this line directly. Okay, no need to perform an AND operation because both is 00 is mean that is inside the clipping window. If not, we need to perform the logical AND operation for both region code. Okay, we need to perform the logical AND operation. If the result from this logical AND operation is not 0000, okay, if we perform logical AND operation and the result from this is not 000, so we can just reject the line directly because it shows that is outside the clipping window. But if the result from this logical AND operation is 0000, okay, if the result is 00, is indicate that we need to perform clipping because there is partially inside and also partially outside. Okay, so if the result is 000 and 0 after you perform a logical AND operation, what you need to do is we need to perform clipping, which is step number 1, which is you need to choose an endpoint of the line that is outside the window, and then we need to find the intersection point of the window. Okay, we need to find the intersection point like we did in the previous example, and then we need to replace an endpoint with the intersection point and update the region code, and then we need to repeat the step number 2 until we find a clip line ideally is directly accepted or directly rejected. Okay, and then once we done for this intersecting point, we need to repeat step number 1. Okay, for other line if have other line that we need to check. Okay, if only one line that is going through clipping window, so just one time only, no need to repeat. Okay, I hope you understand this line clipping algorithm of the Cohen Sutherland.